representation of numbers. Okay, represent numbers. So it's simple. You can represent numbers in this form. Okay, you can represent number in this form. Okay, or you can represent numbers in this form, the logarithmic form. Okay, so how do you write all these forms of numbers? So let me just do two forms of numbers parallel to each other. Okay, so that way you will understand in a better way. So for the exponential functions, you can refer to my previous video, all the rules explained in that video. Okay, and for the logarithmic function, you can stay over here. Okay, so for example, if I write 2 power 0, that is equal to 1, then 2 power 1 is equal to 2, 2 power 2 is equal to 4, 2 power 3 is equal to 8. Okay, and similarly, if we represent this in logarithmic form, we can write it as log of 1 is equal to 0. Okay, so the 1 is the answer over here. And or what if I write it that way? Okay, so I'll write it as 1 is equal to 2 power 0, 2 power 1 is equal to 2. Okay, 2 power 2 is equal to 4, and 2 power 3 is equal to 8. Okay, and now it would be fairly much easier to understand that log of 1 is equal to 0, log of 2 is equal to 1, log of 4 is equal to 2, and log of 8 is equal to 4, is equal to 3. Okay, so basically this corresponds to these things. Let me just minimize the powers so that they're more clear. Okay, so what I have done over here is that 1 is here as log of 1, and the power has become the answer. So basically it is a way to bring the power down. Okay, bring the power as a number. Okay, so that is how we represent an exponential form into a logarithmic form. You can I can just show that to you once again. So 1 is equal to, let me just do it over here, 1 is equal to 3 power 0, 2 is equal to 3 power 1, no, it's actually 3, my bad. Okay, 3 power 2 is equal to 9, 3 power 3 is equal to 27. Okay, so now if you write it in logarithmic form, what will you do? Just follow the drill. Okay, so the 1 would become the power 0. Okay, so that 1 come over here, and that 0 becomes the answer. Okay, then we have log of 3 is equal to 1, log of 9 is equal to 2, log of 27 is equal to 3. I know it might not be how you write it on your calculators, but just stick with me for a bit and you'll understand what I am doing. Okay, so let me just write it another example for better understanding. Now you will also do it side by side. Okay, so for example, if I have 1 is equal to 10 power 0, okay, then we have 10 is equal to 10 power 1, 10 power 2 is equal to 100, and 10 power 3 is equal to 1000. Okay, and when we write it in logarithmic form, what we do is that log of what? Log of 1 is equal to 0. Okay, log of 10 is equal to 1, log of 100 is equal to 2, and log of 1000 is equal to 3. Okay, so if we see all these examples, we can see over here that there is a common thing. Let me just erase the lines. Okay, so if we see all these examples in the logarithmic ones, you can see that log 1 is equal to 0, log 1 is equal to 0, log 1 is equal to 0. So that means that let's say like log 2 is equal to 1, log 3 is equal to 1, log 10 is equal to 1, right? So that means that log 2 would be equal to log 3 would be equal to log 10, but that's not true. That's not entirely true. Okay, so what do we do to differentiate these things? We just insert a base, that is this 2. Okay, and over here we will do a 3, because the 3 is the base over here. Okay, and over here we'll do a 10, because the 10 is the base over here. Okay, so that way we can differentiate, and now it would read as log of 2 to the base 2. Okay, so that way we can differentiate between how you write log, right, and that will give it a distinct value. Okay, and then we have log of 10, log of 10, log of 10. Okay, so that is how we basically write log. Okay, so that is simple, right? Now if you have something like log of 10 power 1 so is equal to 0, you can write it in exponential form as 10 power 0 is equal to 1, right? Because you know that this comes over here and this comes over here. Okay, and then the log disappears. Okay, so that is fairly easy to understand. Okay, and so now let's see observations that we make from here. We can term them as rules of logarithm. Okay, so what first observation can we see is that log of 2 to the base, log of 1 to the base 2, log of 1 to the base 3, and log of 1 to the base 10 all are equal to 0, which means that rule number 1 can be written as log of 1 to the base of any number m would always be equal to 0. Okay, the second observation that we can make is let's say that over here, yeah, so over here we can see that log of 2 log of 2 to the base 2 is equal to 1, then log of 3 to the base 3 is also equal to 1, then log of 10 to the base 10 is also equal to 1. This means that log of m to the base m would always be equal to 1. Okay, the third rule or observation we can make over here is that, in which we have already seen from this example, that for example if we have log of 10 to 100, that would be equal to 2, and we have to represent this in exponential form. What do we do is that we do 10 squared is equal to 100, so the power becomes the answer, and then the answer becomes the power, and the form is converted to exponential form. Okay, so the rule, we can write it as a rule that way, that log of let's say if we have y is equal to a power x, and we have to represent this in logarithmic form. We can, like, this is a reversible sign that it could go either way, and if we have to represent it in logarithmic form, we write it as log of y to the base a is equal to x. Okay, so these are three basic rules of logarithm. Okay, now let's look at a little more established rules. Okay, so we discussed this in previous video as well, that log of a m plus log of a n is equal to log of a mn. Okay, so basically when two logs are adding their powers, the logs, they multiply. Okay, so that is easy to understand, right, by simple indices. Let's say for example m is equal to a power x and n is equal to a power y. Okay, now if we have to do mn, we know that in exponential form, you can see in the previous video as well, that what happens is that when a power x times a power y, so that would be a power x plus y, right? But over here what we do is that we represent these two in logarithmic form. So what we do over here is that log of m to the base a is equal to x, and log of n to the base a is equal to y. Okay, so and we know that a power x plus y, mn is equal to a power x plus y, as we saw over here. Okay, so mn is equal to a power x plus y. So log of a mn, if we represent this in logarithmic form, what will happen is that log of a mn would be equal to x plus y. Okay, so that way we can see that now we have two basic things, this over here, and then we have this. So when we have x plus y, just a second, x plus y would be equal to log of am, this is the x and this is the y, plus log of an, and we know that x plus y is also equal to log of amn, right? It would be log of amn. So that proves our rule that when two logs add, their powers multiply, and I have written this over here. Okay, so that is fairly intuitive to understand. Similarly, when two logs subtract, okay, when two logs are subtracting from each other, log of a m minus log of a, and then the answer is log of a m over n. Okay, then the basis, then the logs divide. Okay, and another rule to remember is that these are never negative. Okay, for example, if we have, the another rule is, you can prove it as well, but I'll just write it over here simply as another rule, and which is that if there is k log of a m, that would be equal to log of mk, m power k, basically m power k, and to the base a. Okay, so basically when there's a constant multiplying the log, it becomes the power of the power. Okay, so these are the basic rules of logarithm. Okay, so another observation that we can make, or you can check it on your calculators as well, that never ever is any of this negative. Let's say if we have a, like the base over here, a would always be positive. Okay, you can check log of 4 minus 1, this minus 1 will give the answer as negative. Okay, and then we will have m, which would be greater than 0, and n would also be greater than 0. Okay, so m would also be greater than 0. And also log is defined for positive exponents. For example, if we have 2 power 2, then we have 4, right? This if we represent it 2 power n, then log is defined. But if we have 2 power minus 2, then log is not defined. Okay, so this means that n should also be greater than 0. Okay, so these are basic rules of log. Another very small thing about log is that this LG, you'll look around LG many times. So this LG means common log. Okay, and this is basically, when we write LG4, it basically means log of 4 to the base 10. Okay, similarly like this over here, so we can represent this as LG1000, LG100, LG10, LG1. Okay, so that is it for log. I'll meet you in the next video.